All right, this is the video for 2B1. There's only two real examples on this one because this is mostly covered in the pre-video for this week because this is a topic that a lot of times students have seen before. So we're going to go through it just to make sure we know how to do each type of example, and then we'll have a second video for the 2B2. So 2B1 is our mean, median, and mode. Susan randomly selected a sample of plants to determine their average height of the total 35 plants in her garden. She measured the heights in inches of 8 randomly selected plants and recorded their data. So this, even though she has 35 in the whole population of her garden, she's doing just a small sample of them for the mean, median, and mode. Okay. So we have to, first of all, for mean, we're going to add up each of those values, and mean is usually X bar. That's the little symbol we use if it's a sample. So we have 2.5. We're going to add that to all the other numbers. So 3.5 plus 4.2 plus 4.5 plus 4.8 plus 5.3 plus 6.0 plus 6.2. And that is a total of 8 plants. So we're going to divide by the number of items, which was 8 plants. So we add 2.5 plus 3.5 plus 4.2 plus 4.5 plus 4.8 plus 5.3 plus 6 plus 6.2. The numerator we get is 37. We're going to be dividing that by 8. And that gives us 4.625. Now, they did not tell us to round, so I'm just going to write that out since that does stop. It's a terminating decimal. We're going to look for the median next. The median is the middle. So first of all, you have to make sure your numbers are in order from least to greatest. Now, they already are in this specific example, so we were kind of nice to you there. If you have an odd set of data, which we do not, we have 8, which is even, sorry. So if you have an odd set of data, there'll be one number in the middle once you've ordered it from least to greatest. If you have an even set of data, which is what we have, your middle is actually splitting the numbers in half. So we have to average the two middle numbers that are on either side of this. So 4.5 plus 4.8, and then we're going to cut that in half. Okay. So 4.5 plus 4.8 is 9.3. Divide that by 2. And that'll give us an average, or not an average, but a median of 4.65. So notice they're not too far off from each other. The mean is a little bit smaller than the median, but not tons. And then we need to find the mode. Now, mode means that your data point that happens the most. So in this specific example, every single item is unique. None of them are repeated. So when that happens, there is no mode. So we just say none. If you have two items that are both the same amount, like say you have two 4.8s and two 3.5s, if they both occurred more than everything else, you would have two modes. You'd list both numbers. If you have one that occurs more than everything else, you'd list that one. But for our case, since everything was unique, that means no mode. Okay. And then the only other one in section 2B1 is just making sure we understand if something is a population mean or a sample mean. So the question becomes, did they use every data point in their in the group that they're looking at? That's, if they do that, that's a population mean. If they take a smaller sample of that group and do the average of that, then that would be a sample mean. So it says the university administrator is interested in determining the mean salary for all 50 advisors at the university. So there's a total of 50 advisors at the university. Calculate the mean, the administrator adds all of those salaries together and divides by the number of salaries, which is 50, to arrive at a mean salary of 54,000. Is this the sample mean or a population mean? Well, since they had only 50 advisors at their university, and they used all 50 when they averaged, this would be a population mean. Now, if the wording had said something like, to calculate the mean, they picked 10 of the advisors and then averaged their salaries, that would have been a sample mean, because they would have taken a smaller subset of the big group. Okay, and that's it for 2B1.